A hyperbola is the set of all points in the plane such that for each point P, the absolute value of the difference of the distances from two fixed points is a constant. For an ellipse, the keyword was sum. For a hyperbola, the keyword is difference. And a hyperbola looks like two sideways parabolas. There's lots of terms here. It says each fixed point is called a focus point, and the distances from the foci to a point P on the curve are called the focal radii. So again, by the definition, any point on the hyperbola, if I connect to the two focal radii, the distances will always be the same. For instance, let's say I have a point right here. And if I said the distance from here to F2 is 4, maybe from here to F1 is 20. So if we subtract these, we get 16. And if you went the other way, you get negative 16, which if you absolute value is 16. So any point on the hyperbola, if you connect to the two focus points, the difference when you take the absolute value is always the same. Hyperbolas can go left and right or up and down. If they go left and right and the center is the origin, the equation looks like this. So it looks like the equation for a for an ellipse, but there's a minus sign between. Asymptotes for a hyperbola that's going left and right are always in the form y equals plus or minus b over a times x. If the hyperbola goes up and down, like here it goes left and right, but they could also go up and down, then y squared must come first. So here's your basic equation. If the center is the origin, and here the asymptotes are y equals plus or minus a over bx. So example 1, write an equation for a hyperbola with the focal rate, the foci of negative 5, 0, and 5, 0, with the focal radii differing by 8. So what's happening is this. Since the focal radii are on the x-axis, x is going to come first. So I know it's in this form. The center is the origin because that's midway between. And if the focal radii differs by 8, we just set 2a equal to 8. And you get a is 4. And if you look at the equation up here, the formula says x squared over a squared. Well, 4 squared is 16. And even though we don't know this, for a hyperbola, the relationship is c squared equals a squared plus b squared. For an ellipse, it was the minus. For a hyperbola, it's plus. So c squared equals 16 plus b squared. And we're trying to find b squared. C is the distance from center to foci. 0, 0 to 5, 0 is 5. So 5 squared is 25 equals 16 plus b squared. So b squared is 9. So if I plug it in, I get this. If I graph that, what this looks like is this. I would go left and right, the square root of 16, which is 4. I would go up and down, the square root of 9, which is 3. And if I made a box, it looks something like this. And then through the corners of the box, in the center, you would draw in the asymptotes. And because the hyperbola is going left and right from these vertices, we would draw these two sideways like parabolas, which are called hyperbolas. That would be the graph for example 1. Those are the notes from page 7 on section 10.4.